Hi everyone, I think you can hear me. Just give me confirmation quickly whether you can hear me or not, and give it a thumbs up. Hit the like quickly and share the video. Welcome back to the session, network analysis. Today's session is network analysis. I hope you must have gone through our website and you must have checked our courses. Trial courses for 365 days. You can check it. Give what's that? PI to try is a coupon code. Give that coupon code, and that's it. You'll get it for free. That trial course, you'll get it for free. Okay. Yeah. Let's begin with the session. So we have today with network analysis again and APSPDCL Discom, okay, SPDCL, Southern Power Distribution Company, and 2014 PYQs, previous year questions, network analysis questions. Simple questions are there. I hope you can easily answer those simple questions. Hardly we have about, I think, 19 questions, 19 to 20 questions. And guys were saying previously in the previous session, I just missed one question, missed as in I said I'll be solving it later, but I have not solved it because of the time constraint. I'm taking up that question. Let's see. Let's start with that previous session question. Previous session, because we're doing continuously PYQs, right? Different years, Transco, Genco, Discom, and all these things. So I'll just discuss the question which I accidentally left. I marked actually. This is a question. This is a question. Let me zoom in a bit. I think you can see better. Yeah, this is a question, and I marked as this. I think you're having some people are raising a constraint that this is the answer. Okay, so let's solve it quickly. Let's solve it quickly. As per my records, I have answer as this, but let's solve it. When you have this kind of ambiguity, I might be wrong. My solution, what I have here, might be wrong. Okay, who knows? Because 2 to 3 people were claiming this is the correct one. So let's see. Let's give it a check. So what is given here? In ABCD parameters, ZL by 2 in the T equivalent shown can be represented. Means this is what this part. How can I represent this? That is a question. Okay. So or this, anything. Both are equal. So whatever is here, same thing will be here also. Okay. So let's quickly have a look. What about parameters? We need to find A and B and C and D, and that A, B, C, D will be definitely in terms of ZL and YL. Okay, of course you can directly compare with the standard equivalent circuit, but let's solve it. Okay, and meanwhile let me take some of your questions. If you have any concerns, give it in the comment. So tell me the all gate previous year questions. There are a lot of things happening here. It's not just we are doing. There are many people are doing lot many things. Okay, whatever is possible, we're doing from our side. Okay, we'll see what the best can be done in all the aspects. Because I started with the gate previous year questions, but people are not that much getting engaged, and hardly in one hour session we could cover only 2 or 3 questions only in entire 1 hour. Okay, that's getting a little tough for all of you, because 1 hour time and just 2 questions, I'm also feeling bored actually. Yeah. So it's better if you go with easy questions, then your concept will be improved. Okay, basics, fundamentals will be strong. Once you're good with the fundamentals, then yeah, we can really rock in the higher level questions. So with that motto, I'm just taking up the level 1 questions only I'm discussing. Okay, so just take them as a gate questions. It's all right. What's wrong in taking that? Okay, but they will be helpful in clearing and getting a good foundation. That's the motto of having these sessions. Okay, and you need to improve your confidence. You need to gain your confidence. For these simple questions itself, if you guys are having issues, then that's a big concern. Anyways, to start with, what do you think? What is the answer for this? What do you think? What is the answer for this? Let me give again time for you also. Give the answer. I'm giving 60 seconds time. What do you think? What is the answer? Quickly, we have got a lot of questions today. This is these sessions, normally this is the time usually students lose the confidence. That should not happen. Everybody is coming up with the gate questions, and if I also come with the gate questions, then you may get stumbled. Okay, so these sessions will improve the confidence, so that when you're solving these simple questions, confidence will be improved. Okay, that's a motto. Anyways, Reddy has answered correctly. What about you all? What are you all doing? You're quiet, you're not hitting the like also, and you're not sharing, and you're not even participating in the chat. What are you doing? What are you doing? Sai Varun, Janit, Reddy, Srikanth. Who else are live? Just respond in the chat. Respond in the chat, so that I'll see who are present. No? Quite? Okay. Yeah. Yes, Gopi. Yeah, you need to respond. Unless you respond, how will I know, dear? That's good. That's good. Your response will be giving us some energy, right? Yes, Sai Kumar. Good. Did you like the video or not? All of you, those who are live at least? No. Okay. Let's continue with the session. So ABCD parameters or transmission parameters. Okay. So find out the value of A. We know what is A. A is V1 by V2 when I2 is equal to 0. Right? Means keep this open circuited, and find out this V1 by V2. What is V1 by V2? V1 is input voltage here. This is V2. V2 is, there is no drop here because open circuit, so I can simply discard it. Oh, nice. Gopi, you're doing good. That's a good thing. Concentrating on a question. Too much concentration is also not good. You should give the energy, right? When somebody is asking something and without answering it, you're concentrating. Good guy. Seems to be too good. But you have not answered also, Gopi. You concentrated nicely. How you answered it? Anyways. Yeah. What are we talking? What I was discussing? I'm lost. V2. Yeah. V2 value. V2 value is simply apply voltage division rule here. Apply voltage division rule. I said courses, voltage is a boy. Voltage is a boy and current is a girl. That makes us to remember the formula very easily. Okay. So if you take that V1 into 1 by YL by simple voltage division I'm applying here. I'm not doing anything. Plus 1 by YL. Okay. Just simplify this. V1 get cancelled, YL is cancelled, and you will get, if I'm not wrong, ZL by 2 into YL plus 1. Just simplification, mathematical simplification, you will get this. Okay. Now we want ZL by 2. That's what is asked. ZL by 2 is asked. So from this I can write ZL by 2 is equal to A minus 1 into divided by YL into 1 by YL. That's what ZL by 2. So do you have any option here? We don't have any option. It is given in terms of C. Okay, it is given in terms of C. So we need to find the value of C in terms of YL and Z. So focus on finding out C. C is equal to, what's the formula for C? Tell me, all of you, what is the equation for C? In case of ABCD parameters, C is equal to, get ready with your pen and paper as well as networks copy. If there is something you can quickly refer and you can give it the answer, not a problem. There is nothing wrong in referring to your copy and answering. It's okay. That's how you're recalling, right? You're recollecting your notes, you're referring to your note. That's a good sign. You do it. Yeah. What is that? What is the value of C? No one. No one. How crazy is this? Isn't it crazy? Yeah, somebody has responded at least. Whether it is right or wrong, that's a different issue, but somebody has responded. I2 by I1. I2 by I1, somebody is saying. So is this right? Is this right, I2 by I1 for C? It is I1 by V2 when I2 is equal to 0. In same open circuit condition and I1 by V2. Now what's the value of I1? I1, let's take it as it is. Yes, you're right. That's what I'm saying. You can keep your copy with you, not a problem. You can keep your copy, network copy. Get ready with your pen, paper, rough paper, so that you can quickly do it. Okay? Yeah, V2 is equal to, what is V2? Tell me. V2 is equal to simply current. What is the current flowing in this? I1 is the current flowing in this. Okay, so V2 is equal to I1 into YL. I1 into YL. So answer is 1 by YL. Am I right? No. What the hell I'm doing? I1 by IL. I1 by YL. Because V is equal to I into Z. If you want to write in terms of admittance, then that would be I by Y. So I1 by YL. So that gives us YL is equal to C. That's what is C. That's what is YL. So in place of this YL, I can keep C here. So A minus 1 into 1 by C. Yeah, you're absolutely right. This is the right answer, not this. This is the right answer. Okay. Let's go to the today's session. Okay. This is what the previous session that was. I need to solve this. I said I'll be solving it because of the time constraint. I couldn't solve it. That's why I solve now. Now I'm moving to the today's question. It's an easy question. Here is a question. Let me zoom it a bit. Maybe a little more. I'm giving 60 seconds. Gopi, your time has begun. Start solving and answer it quickly. ASAP. If you are engaged till the end and you're answering correctly, then you will get a chance. You will get a chance to get a free test series from exam.pi2.in. Every live session I'm announcing one person as a winner, and that person is getting a free test series from exam.pi2.in. and you can buy these test series others if you want just at 99 rupees. 99 rupees. You will have questions as well as solutions. Lot many test questions, around 1,000 questions. Many questions are there. You can just check that website, exam.pi2.in. You'll get to see everything. You can check the link in the description also for the exam portal, online exam portal. Yeah. Ready. What about measurement subjects? Measurement subject, I don't think there won't be any further course launches from PiSquare this from before 2021. Already we launched those courses. For now, we're not planning for any launch. Because you know, right, we don't launch a course just for the sake of launching a course. I think you must have seen, experienced our networks course, power electronics course and machines course. There are a lot of simulations, a lot of experiments, 3D animations. A lot of work has been done just to bring you that product. Okay, not just teaching. We're letting you feel the beauty of engineering actually. We should not never afraid of any subject. That's what the main motto. Once you take the courses, definitely you're going to feel that. Yeah, go and get the trial. Go and get the trial course. Get a free trial. Visit lectures.pi2.in, which is scrolling, moving. Catch it. And go to that website. Get a free trial. Okay, anyways. Answers. We got the answers. 101. Somebody's saying 5. Somebody's saying this. Somebody's saying something. Okay, let's see. A circuit with R is equal to 2 ohms, L is equal to 1 Henry is excited by a step voltage of 10 volts at T is equal to 0. Step voltage, see here. Step voltage means it's like switching is done at T is equal to 0. It's just like you have turned on the switch. You have turned the switch on at T is equal to 0. Instead of giving this representation, you can simply say it as a step input. That's all means the same. Anyways, so if I represent in terms of a circuit which might be convenient for you, we have a resistance and we have an inductance. This is 1 Henry, this is 2 ohms, this is 10 volts. The current at t is equal to 10 seconds may be taken as. So what is the current equation here? 10 by, yes, what is the current equation? Steady state value is 10 by 2 into, what is the formula? What is the formula? Yes, what's tau value? Find the tau value. What is tau? L into R? L by R, not L into R. So that is 0.5, 0.5. So 1 minus e power minus 0.5. Sorry, why I'm writing this? T by tau, right? T by tau. T value is 10 seconds. At 10th second, we want what has happened to the current? 10 by 0.5. Okay. So you simplify this. Are we doing correctly or are we doing something wrong somewhere? No, everything is correct. You will be getting 5 minus 5 into e power minus 20. Okay. So e power minus 20, get a calculator. I have a calculator. 5 into e power minus 20. Yeah, tell me, how will you do if you don't have a calculator? Suppose it's not a gate exam, right? If it is gate exam, you'll have a calculator, but you don't have a calculator in case of any other exams. So that's what you can approximate. E power minus 20 will be very small. Okay, so you can make it 0, approximately close to 5 ampere. That's how we can answer it. Why are you taking the resistance in the denominator encyclopedia? That's what the transients case. Transients, if you are basically good with the transients fundamentals, then you will understand why it is only resistance. Okay, it's a DC circuit, right? Anyways, that's the fundamentals of transients. Let's go to the next question quickly. I'm giving again 60 seconds time. Try to answer this. The timer is running here. I think you can see the timer here, right? Timer is moving. Yes, Gopi is responding nicely. Did you share that video? Did you like the video? Did you share the video? No likes, no shares. I think let's end these sessions. Why I'm spending a lot of time? If you're not doing that, then I will slowly reduce the sessions. Yeah, maybe I don't think, I'm not sure whether you can expect the next sessions or not. It's serious. It's not just I'm threatening or something. There is nothing to threaten, right? Just a casual discussion. Yeah, good. Quick answers. Encyclopedia has been doing good. Nandish is good. Yeah, you got 2 more seconds. 1, bam, 0. Time's up. Hari Gopal. The sides of power triangle XYZ as shown in figure below. The usual notation XYZ represents. Usually, what does it represent? XYZ. This X is definitely, this is what? S. Okay, power triangle, right? Power triangle means what are the powers you have? You'll have P, you'll have Q, you'll have S. So, this is S. P, S is equal to square root of P square plus Q square. So, from this you can write, from this triangle, X seems to be very clearly Z square. So, S and X both are same. So, X, Y, Z. So, either these can't be the answer, either this or this. Okay. So, these are in phase component. That's what the power, active power P. Okay. So, I prefer to give this as answer, this is answer, because x-axis along with the x-axis we do normally represent with P. That's why I'm representing with P. This is reactive power quadrature component Q. This is S. So this is answer. Those who are saying 2 as answer, you need to consider rechecking it. Okay. I'm moving to the next question. Yes, reactive power Q. Yeah. Yes, Gopi. Next question. It's an easy one. Seems to be a little worrying thing, but yeah, it is easy. Transfer function XYZ, don't worry about this. It's still a networks question. You can still do it. Yes, 7 cm. Oh, We have CM, a common man 7 with us. Are you common man or a chief minister? You must be a common man. Yes, Sai Raghav is also back. Wow, very quick response, dear Sai Raghava. I think you must have answered. Nice, good response. What about others? What are you all doing? What are you all doing? All of you, I'll get to know your presence. I want to know your presence. I want to feel your presence. Say, give it a comment. Give it something in the chat box so that I'll feel your presence. Then I'll get some energy. In the chat, say hi, say bye, say X, say Y, say anything in the chat. Anything means not nonsense, obviously. Anyways, time's up, time's up, time's up. What are you thinking? Transfer function means, are you thinking something else? Transfer function is nothing but output by input. Of course, Laplace transform of output by Laplace transform of input. Same output by input. If we study in machines, then we'll call it as efficiency. Same output by input. If it is analog electronics, we'll call it as a gain. Wow. Same equation, right? Same thing. If it is in measurements, change in output by change in input, we'll call it as sensitivity, isn't it? What the heck, man? Same output by input, but subject changes. It changes. Name changes. Yes. How nice is this thing? But you should not get confused after all. Anyways, this is output by input, Laplace transform of output by Laplace transform of input. What is output here? This is in farad. Convert into S domain. Convert into S domain, because in all the options we have S domain. Convert into S domain. If this would have been an inductor, it is L into S. If it is a capacitor, 1 by C into S. And this S domain, any domain, it stays as it is because it is not having any frequency term. Okay, we know Xc is equal to 1 by omega C. This is in frequency domain. This is in frequency domain. Omega is frequency. In S domain, change simply omega with S. That's it. Here also, XL is equal to omega L. In case of S domain, change this omega to S. That's it, SL. For an inductor. This is for a capacitor. Okay. So, now I'll not look at this. Rather, I look at 1 by Cs. C value is given as 1. So, remove this. Okay. Now, what is the unit of this? Can somebody tell me what is the unit of this 1 by S? Quick. Give it in the comment. Give it in the comment. Give it in the comment. What is the unit of this 1 by S? Who the hell? Who unlike the session? Oh, Gopi. People will be there, dear. Nothing to worry. Let's enjoy the likes as well as unlikes. Nothing to worry about it. People are always there. Some crazy guys will be there. We don't have to worry about it. Yeah, I'm asking a question. What is 1 by S unit? What is 1 by S unit? I'm asking you. I want to know. Nation wants to know. I want to know. Farad inverse? Yes, Sai Raghava, you're right. It is ohm. See, what it did, here it was omega was there, isn't it? Omega was there. What is the unit of this? It is ohm. I replaced this with S. That's it. So it is still in ohms. It is still in ohm. 1 by S is ohm, not anything else. It is ohm. Key point, key point. Now, once you are done with that, simply output is apply voltage division rule 1 by S by, I mean to say, V input into voltage division rule I am applying here. I am not doing anything, or else let me make it more clear. Let's take this one as Z1. This is Z1, this is Z2. Now tell me, what is the voltage across Z2? Simply V1 into Z2 by Z1 plus Z2, right? So what is this Z2? Z2 is equal to 1 by S, ohms, right? It is given in ohms. And Z1 is simply 1. Z2 is 1 by S. You bloody solve this. You bloody solve this. You are going to get V2 of t. You will get V2 of t. So V2 of t. But what I want V2 by V1. Sorry, I should not say V2 of t. I should say V2 of S, because we're doing an S domain. So if you bring this to here, and you will left with what? You will left with 1 by S, and this is simple LCM. I think SS get cancelled, 1 by 1 plus S. This is answer. This is answer. Simplification. Simple simplification rather. Okay, I'm on to the next question. There are a lot more questions to solve. Shall we go to the next question? Give it a thumbs up. Give it a thumbs up. I'll go to the next question. Yeah. Done? Where is the thumbs up? Yes. Next question. This is bloody 30 seconds question. If you are taking more than 30 seconds, then what to do? Okay, take it. Okay. That's an easy one. Rahul, you're back, but I don't know what happened to you. Last two questions, you're not performing that good. Read the question, no need to be in a rush, Rahul. Yes, Sai Raghava, you're absolutely right. Continue till the end. You might get a chance to win the test series today. Rahman, Habib Rahman. 2. What is the unit of L by R is what? Time constant. Time constant. It's a time. It's not a constant. It's a time. Okay. So seconds. This is also having time constant for RC circuit. It is also seconds. Omega L by R. It is a quality factor, isn't it? Quality factor. Omega L is having unit ohm. Resistance is having unit ohm. Ohm, ohm, Baba, ohm cancelled. Means no unit here. 2 pi by omega. We know omega is equal to 2 pi f. So 2 pi by omega is equal to 1 by f, that is time period. This is also having unit seconds. Rahul, this is also having unit seconds. This is the only thing which is odd man out and is having no unit quality factor. So answer for this question is exactly encyclopedia, you're right. Let's move to the next question quickly. Yeah, this is also easy one. I'm giving again 30 seconds. Just 30 seconds I'm giving. Just 30 seconds I'm giving. Easy. 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 Yes, Janet, you're right. Let me go to your comments meanwhile. What are you commenting? RC Raghu for Nandhish. Good. Voltage division. Yeah. Time's up. Give it a thumbs up those who are watching now. Give it a thumbs up those who are watching rebroadcast. Give also a thumbs up. Whatever you're doing, give it a thumbs up first. Done. Time's up. Answer you're saying 4. Absolutely. All of you are right. When frequency is changing, we have a video on if frequency changes, how impedance is changing, how everything is changing. We have a YouTube video. You can check that YouTube video. There with the simulation, I have shown you graphical representation. Simulation will automatically keep changing when you change the values. Okay. So that is there. You can check it. Then you will get a better idea about this resonance concept. You can check our YouTube channel there. You will get it. Okay. Yes. With respect to, we know at resonance, circuit will have, especially we have RLC circuit, it will have only resistive in nature. In this is the only resistance. This is reactance component. This will not be there at resonance. Only this is there. So answer is this. Shall we go to the next question? Thumbs up. I'll move to the next one. I'm moving to the next one. Yeah. Oh, nice. Think about it. Think. Good. Rahul, Nandish, RS Tech, Encyclopedia, Pakka 3. Good. That's a confidence. Darshan, you got 3 seconds, 2, 1, bam. Time's up. Okay. Good response for this question. See, 2 wattmeter method, careful here, because questions used to come from this 2 wattmeter method. I'll give an interesting point. Try to keep that point in your mind. Then you can answer almost any 2 wattmeter method question. Not any, almost any. Are you all ready? Yes, you're right. 2 wattmeter method, 3-phase power measurement of a balanced load. One of the wattmeter is giving negative. We know 1 wattmeter, W1, remember this, W1 is proportional to cos 30 plus phi. W2 is proportional to cos 30 minus phi. You just bloody remember this. That's it. If you remember this, you can answer almost any questions from 2 wattmeter method. Take a pen and paper, write this quickly. Now, if 1 wattmeter is showing negative, means we know cosine will be negative if angle greater than 90 degrees. Okay, so W1 to be negative because it is having a plus, so W1 will be negative. W1 to be negative, this must be more than 60 degrees. If it is more than 60 degrees, then only 30 plus 60, it will be more than 90 degrees. If it is more than 90 degrees, you are going to get cosine negative. So more than 90 degrees means phi is more than 90. So power factor, phi is what? Power factor angle. So power factor will be less than 0.5. Who answered correctly? Who answered correctly first? Yes, Rahul. Rahul is the one. I hope, Rahul, you are doing good. I think, yeah, you are the one, right? Rahul, give me your email ID once again in the comment. Yes, next question. This is 30 seconds question. Yeah, I have received. It seems you're still in hospital. Nothing to worry. You're going to get something from PiSquare. Yeah. Maybe today or tomorrow. Good. Yes, time's up. Only one answer. Nandish has answered correctly. Nandish, keep it up. RS Tech, okay. One is answer, good. The network has 12 branches and 8 independent loops. The number of nodes is equal to. What is the formula? Can somebody say what is the formula? What is the formula? Number of formula I want. Yeah. Sure, Gopi, that's good. What is the formula? I want to know the formula. What is the formula for this? Yeah. The number of independent loops. Formula. We know the formula. Number of independent loops exactly. Number of independent loops is equal to B minus N minus 1. Okay. You subtract number of branches. And this is what? N minus 1 is number of non-reference nodes. Okay. So here this is given. Number of independent loops are given, that is 8. Number of branches are given, that is 12. You are pretty asked to find out this N. That's it. Yeah, you're right. You're absolutely right, Encyclopedia. So answer is 1. Means 5 number of nodes will be there. Shall we go to the next question? Yeah, mil gaya Rahul. I got it. Give it a thumbs up. I'll move to the next question. And like and share. And if you are new, subscribe. Gopi, it seems you are new. Subscribe to the channel and ring the bell. Why ring the bell? If you ring the bell, you'll get notified, otherwise you'll miss it. Yeah, this is, excuse me, there is a trap. I don't know how many are going to get trapped in this question. Let's see whether they'll be trapped or not. Yeah. Mm-hmm. Mm-hmm. Nice, nice. Okay. The equivalent resistance in ohms. It is asked, what is the equivalent resistance in ohms? What is this 2S? Is this 25 or 45? Is it 25, 45? Yeah, what is this S? Tell me. Somebody. I want to know. Yes, Siemens. This is the inverse of ohm, Siemens or mho. Okay. So when this Siemens is there, what is the resistance then? What will be the resistance? 2 Siemens means resistance is 1 by 2, and this is also 1 by 2 ohms, because the result is asked in ohms, so you should give it in ohms. Now let's add these 2 ohms. That's it. Am I doing right? Yeah, that's supposed to be. When you add these 2, what will you get? When we're adding, I'm getting 1 ohms. We don't have that answer here. How come? What happened to this? How come you are getting 0.74? Yes, it is 1 by 4. Sorry. This is 1 by 4. I did it as 1 by 2. Okay. So 1 by 2 plus 1 by 4 is the answer. Okay. 4 and 3. So 3 by 4, this is answer. Yeah. Sai Bhargav, good. Second. What is the second? Next. Yeah, let's see. This is the one who answered this correctly. You will not get obviously free course, but you'll get something special from PiSquare. Oh, you have reached home. That's good. It is given admittance. Okay. Kidding with LB. Please don't feel bad, sir, but subscribed many months ago. It's okay, dear. It's okay. What? I'll never feel bad if I'm in a good mood provided. Yeah. Wow. Good answers. So at least people are responding. That's good. Let's see now. You have 2 seconds more. Bam. Time's up. Let's see what is correct. Yes, Sai Bhargava. Yes, Banerjee. Yes, Anand. Yes, Encyclopedia. Very good. Can you quickly give how you got that answer? So that if your approach is something different and good, then I told you, right, you're going to get something from PiSquare if you got it correctly. So give quickly what is your explanation for your answer, so that you'll get a chance to win that. Anyways, the total charge in the capacitor is doubled. Q is equal to C into V. Q is doubled. Q got doubled. Then what will happen to the energy? What is the energy formula? Energy is equal to half CV square. So can I say this is equal to half Q into V? Energy is equal to half Q into V. So charge got doubled, so the energy will be doubled. Obviously, both are proportional, isn't it? How simple equation is this? Q is equal to half CV square. How come Q is equal to half CV square? Okay. Anyways, you're right, who have answered. All of you I think are good, decently good. C is proportional to Q. Q is equal to CV square. So encyclopedia has responded first. Yeah, encyclopedia has responded first and correctly, so I'm convinced. So encyclopedia, give your email ID in the comment. It's not actual final winner announcement, just a complimentary thing. Give your email ID, we'll send you something. Yeah, this question, 30 seconds question. Yeah, timer is running. Yes, I got it. I got your email ID. Give it a thumbs up quickly. Thumbs up, thumbs up, thumbs up. Wow, nice. Good, good, very good, very good. What a response, what a response. I thought you would be answering this. Tell me, what is the question for this answer? What is the question for this answer? If I say this answer, what should have been the question? Tell me. Yes, for now, this answer. That's right. Yes. Yes, you're right. You're right, encyclopedia. That's a quick response. If this would have been a KCL, this is right, but this is a KVL, Kitch voltage law. Kirchhoff's voltage law, not Kitch. Okay, not Kitch. Let's go to the next question. Wow. 50 seconds only. Only 50 seconds. Like the video. Did you like the video? Why you are watching without liking the video? Like the video. Yeah. It's on demand. Not on demand, it's up to you. Up to you. Just I'm reminding you, that's it. Yeah, good. Wow. You got 10 more seconds. 6, 4, 3, 2, time's up. Time is up. Current in the below circuit. Simply apply KVL. If you want to know the fundamentals, how the fundamentals, you just go and take trial course of network analysis from the website, free trial. Just check this link. It's going. Just catch that link and go for network analysis. Get a free trial, then all your fundamentals will be very clear about the networks. Unless you are good with the networks, you're not, at least the basics of networks. Write the KVL to this. Minus 36 plus I0 into 4 plus 5 I0 is equal to 0. Now simply I0 is equal to how much? Solve it, you will get this. I know a lot of students, even good pointers, those who are having good pointers also will struggle in applying the basic fundamentals. Okay, that's why I have designed a few interesting rules. If you go with those rules, number 1, you're not going to forget. Number 2, you will get to apply the concepts what you learned. It's not just learning, it's an application. Application is a key aspect. So just go and get the trial course. So you will get to apply the concepts. You will also enjoy the concepts. Okay, free trial, right? Get it, man. Next question. This is 10 seconds question. Good. Give it a thumbs up. Like the video. Share the video. Share your love. You're asking me to. So do the sessions, more and more sessions. And You are bloody lazy to click that thumbs up. This is, don't you think it's crazy? It's not lazy you are, it's crazy you are. You are crazy. It's a crazy, 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 crazy feeling. I'm remembering a song. Yeah. Is this a question, dear? It's a previous question. See how simple is the question. What is this? It's a voltage dependent. You have voltage, and this is a current source. Voltage dependent current source. Voltage controlled current source means the same. These answer. Yeah. This is going to the fun. This is the question. The one who answered this question correctly, you are going to get a free test series package from PiSquare for today's session. Let's see who is going to answer this question. You got 3 more seconds only. Yeah, time's up. The right answer is, and the winner is, who answered correctly? I didn't follow it. I didn't follow who answered it correctly. I think Rahul is the one who answered correctly. So, Rahul, you're the winner, but you're going to get something different from PiSquare today. So, let's give it to the next person, Nishant Kumar. Nishant Kumar, I'm announcing you as a winner for getting a free test series for today's session. Okay? So, your answer is right. This is answer. A reduced incidence matrix. In case of incidence matrix, number of rows are equal to nodes, number of nodes, and number of columns are equal to number of branches. It is for it's for incidence matrix we're talking about. Now it is given reduced incidence matrix means you bloody take any one node as reference, you remove that node. You remove that entire row. Here it is having 4 nodes. So incidence matrix is having a dimension of number of nodes by branches, that is 4 by 1, 2, 3, 4, 5, 6, 4 by 6. That is for this. So answer is this. No, that's wrong. Because it is asked for reduced incidence matrix, so you need to take off that one row. So n minus 1 cross b, so answer is 3 cross 6. Yes, Nishant, give your email ID in the chat box. You are the winner. You are the winner. Why not me, Rahul? Okay. You want a test series or something more than test series? Tell me, Rahul. Don't say these kind of things. I'm giving better than test series and you want test series only. That's it. I'm planning to give a course for you because I know you're suffering, you're sick and you're not doing good. So I thought of giving you a course and you're asking these kind of things. Why not me means it's my wish because it's my live show. I'll do the way I want. I'm just kidding. Anyways, next question. Wow. Another masterpiece. Yeah, something more than test series. You want a test series or a video course? Tell me. Want test series? Okay. Yeah. Yes, time's up. The answer is careful here. Careful, guys, all of you. All of you. Stop and careful. The existence condition for two-port parameters. The existence condition for the two-port parameters. Suppose, let's talk about the Z parameters. Let's talk about Z parameters. V1, V2 and I1, I2. Z parameters I want. So this way, what I mean to say is V1 is equal to Z11 I1 plus Z12 I2. Okay. For the existence of Z parameters, these two should not depend on each other. If they are depending on each other, then because two-port parameters are conditional parameters, right? Means if I want to find Z11, Z11 is equal to V1 by I1 at I2 is equal to 0. Now if I1 and I2 are function of each other, if they are dependent on each other directly, then if I2 is 0, then I1 also will become 0, isn't it? If I1 also is become 0, this will be infinity. So similarly, there should not be any dependence. These are Y parameters. In case of Y parameters, it's inverse, it's reverse, right? Reverse as in, there should not be any dependency between the voltages. But if you see this network, V1 and V2 are exactly equal. It's not even dependent, exactly they're equal. So if I try to make, they're short circuit parameters, right? If I try to short circuit here, V2 is 0, then V1 also should be 0. So Y parameters doesn't exist for this network. Okay. If the network would have been something like this, for this network, Z parameters doesn't exist because I1 is equal to I2. Okay, I1 is equal to I2. And for this, Y parameters exist, and for this, Z parameters exist. Are you clear? Let's go to the next question. This is an easy one again. Bam. Anand, Vijay, good response. Quick response as well as good response. Yeah. So the answer is, as time's up, answer is this. What is H12, tell me? H12 is, yeah, what is H12? Yes, what is H12? H12 equation as well as H21 equation. H21 is equal to I2 by I1. H12 is equal to V1 by V2. So this is reverse voltage gain. This is forward current gain. Current gain and voltage gain, they don't have any units. They are unitless. Okay, they are unitless. Means they are having same unit. Means no units, both are not having any units. So this is right thing. Okay. Others, they are not, because H11, what is the formula for H11? It is V1 by I1. H22 is equal to I2 by V2. Okay. Clear or not? Shall I proceed? This is having unit ohm, this is having unit mho. Okay. So these are only option which is matching with everything. Yeah, this is an easy one again. 40 is more actually, 30 seconds is good enough. Yeah. Yes, Devi Varaprasad. Yes, Dinesh, you're right. Thanks for such a gift in December. But I'm thinking of changing my mind. why I'm changing mine. Anyways, let me not confuse you. You'll get it. It's easy one. I don't know why you're doing this. You should never do mistake here. You should never do mistake for this question, because these kind of things, if you are preparing for a competitive exam, power electronics, if you can answer, you should be able to answer this quickly. Okay, if you can answer this quickly, then you have a good knowledge in power electronics. Okay, that's what simple techniques are there to solve it, to get this RMS values. Okay, tell me, what is the area of, anyways, let's not get into that stuff. We're already running out of time. We have a few more questions. Sawtooth, this is a sawtooth, right? Once you square this sawtooth, because RMS, I already made a video on finding out RMS, how we got RMS. You just check our YouTube channel. There you will get about complete idea about the RMS evaluation of RMS. There you will understand root of mean means what? Average of squared signal. That is what RMS. Root of average of squared signal. This is a sawtooth. You just square it, dude. Once you square it, you will get this rectangle hyperbola, parabola, something like that. This is what you'll get. What is the area of this? Area of this is peak value by 3. Peak value is how much? It is given Ym, it should be Vm, but it is given Ym. Okay, let's take it as Ym. Ym square by 3 is the area. You must have studied this bloody in mathematics in +2, isn't it? Now, area of squared signal is done. You bloody need to root it. You will get this. Let's go to the next question. If it is discontinuous sawtooth waveform, then wow. Next question. Easy one, I think. Not difficult. I see Rahul is doing really good. Yes, I'm not going to confuse you. You're going to get, I'm saying right. I said it means we'll try. Normally I don't stick to my word. I try to stick to my word. Yeah. What, why are you not answering? Why are you not answering? What are you looking at? Yeah, time's up already. The current in RLC series circuit. So current here, this is a current. So whether to lead or lag or phase or that or this or lead or lag, anything. Let's see. What is omega? Omega is 1000. So omega L and 1 by omega C. Tell me what is the value of omega L. Omega value is how much? 1000 into 0.01, 2 are gone. This is 10 ohms you're going to get. This is 10 ohm. 1 by omega C, 1 by 1000 into 10 power minus 6. We have here 3 and 4, so left are 2. This you're going to get 100 ohms. So it is very bloody clear. XC is greater than XL. What does it mean? This circuit is having morely capacitor reactance dominant. XL is not dominant. And one point, let me say, this RLC series circuit, not this RLC series circuit, any RLC series circuit will either act as RL circuit, or it will act as RC circuit, or even it can act as pure resistive circuit, but it will never act as RLC. There is no nature called RLC. Either R, RL and RC. These are the natures. Okay. So anyways, this is more the capacitance. So capacitance effect, capacitance case, current will lead the applied voltage. We know bloody thing. This is simple thing. Last but one question. Oh, 30 seconds. Where is Gopi? Gopi Gab? Are you there? Are you there? Hashmi, Abhishek, Vijay and Dinesh, Subrat. Yeah. Rahul, you don't have to be in a hurry. Try to be accurate. Accuracy matters first. And I have good expectations on you, and you're doing like this, Rahul. 3, 4. What is happening? Let's see. Easy था, तो गलत क्या हुआ भाई? गलत क्यों किया? An inductor acts as short circuit with the DC. Yes, it is true. DC frequency is 0. Inductor omega L means 0 frequency, 0 ohms means a short circuit. This is right. It doesn't mean Q is also right. Current through the capacitor cannot change abruptly. Why? Why current will not change? Who said current will not change through the capacitor? We have made a video on this, not on capacitor, on inductor, with an experiment. Done a beautiful experiment. Then there I have explained why bloody hell, who the hell is the inductor, why it is not allowing sudden change in currents, how come it will not allow sudden change in currents. There is a video on that. Just go through the video. You're definitely going to love that video. And the application of that video, the application of the knowledge what you learned in that video will be very much helpful for each and every, especially electrical engineers, in machines, in power electronics, in power systems, everywhere that will be helpful. Try having a look. Capacitor, it will not allow sudden change in voltage, not the current. So this is a wrong statement. It can allow current. So only P statement is correct. So Banerjee, Anand, Vigneshwara, Raghava, you are absolutely right. Last question of the day. It's an easy one. Let me still give 30 seconds. Like the video and share the video with your friends. Don't miss to share. Like and share. Hasmi saying, so please teach how to solve these circuits using Laplace. Which circuit you want to use? This circuit. Which circuit, dear? This circuit using Laplace. What is Laplace? Yeah. I think you're talking about maybe RLC series circuit. There, that's what in course I taken complete course based on that only, using Laplace only I had done. That's a simple one rather. That's a good one rather. Yeah, you're right, Rahul. Now let me give you a simple tip. What happened to you, Rahul? What happened to Rahul? I think we should cancel Rahul's gift maybe. He's doing all wrong things now from last few questions. Norton's resistance between terminals A and B. So this is a current source. Open circuit it. Udado. Take it off from the circuit because it has internal resistance infinity. So remove it. And now these two are in series. So 30 and in parallel with 120. Okay. Oh, I thought you are writing with 30 by 120, Rahul. You said 30 parallel with 120. You should have solved it quickly. Why you are writing 30 parallel 120? You should solve quickly. Now, see here, how many times more? 4 times more. You can see 30 and 120 is 4 times more. So answer is very simple. Highest number is 120. Write that. 120 by 4 times more. 4 plus 1, 5. That's it. So this is 2 and 4. Answer is this. 24 is answer. ठीक है साहब. Okay, that's good. Then let's end the session. That's it. We got, I think today participation is good. People have responded good because all the questions are easy questions. That's the questions from APSPDCL's DISCOM 2014. Network questions, around 19 questions have come out of 100 questions, I guess. So yeah, do check lectures.pit.in and get a free trial course, and check exam.pit.in for the test series. Those were the winners for today's session. You're going to get what is that? You're going to get a free coupon through email. Okay. Thank you. See you in the next lecture.